Good afternoon, my beautiful learners. So today I brought you onions. I brought an onion. Here's my onion, one whole of an onion. So I cut this onion into half. I cut it into halves. I have this half and I have the other half. So I have two halves of an onion. If I add this onion with this onion, it gives me a one whole. It gives me one onion. I have one half of an onion and one half another onion. If I add these halves of an onion together, I add them, they give me one whole. So this means that one half of an onion plus one half of another onion gives me one. They give me one whole. So we've proved that practically. So how can you prove that through calculations? So proving that through calculations, I say I have one half plus one half. Remember yesterday we spoke about multiplying fractions. We said if I have one half multiplied by one half, it gives 1/4. Yesterday we said, that's what we said. We said it's 1/4 because we say numerator multiplied by numerator, denominator multiplied by a denominator. 1 multiplied by 1 gives 1, 2 multiplied by 2 gives 4. How about if we have a half plus a half? How are you supposed to solve this? Do you have to say 1 plus 1 equaling to 2 and also say 2 plus 2 equaling to 4, which end up being half? Half plus half giving another half. Is it okay? Is this the way we're supposed to do this? What you must know is that the rule that we apply here when multiplying fractions is different from the rule that we apply when adding fractions. This one is wrong. So when solving for this, a half added to another half plus another half, what do you have to do? Because they have the same denominator, the denominator of here, aka the number below, the denominator is 2. The denominator of here as well is 2. So you just write that denominator 2 down. You just write the 2 as it is because the one of here is the same from the one of here. They are called like fractions. Excuse me. So like fractions is like 1/2 plus 3/2. No, not plus. This fraction is like this one, you know. They like each other. I'm kidding, you know. This fraction is like this fraction. Unlike fractions is when the denominators are different, like 3/5 and 7/12. These are unlike fractions because denominators here are different. So here, these are like fractions because the denominator is the same. So you just write the denominator as it is. And then you add the numerators. So numerator here is 1, another one here is 1. So you're gonna say 1 plus 1, which will be 1 plus 1 is 2. And then you just write the denominator as it is. So that is your answer, but you can't leave it like this. You have to leave it in its simplest form. So in its simplest form is what? Is 1. So that is your final answer. This one is the same as this one. We proved practically, and we also proved it through calculations. We still get the same answer. So you get a mark for, there's a mark just for getting your answer, leaving your answer in its simplest form. Importantly, leave your answer in its simplest form. Let's give another example. Let's say I have 2/3 plus 5/3. What you can notice here is that this number is the same as this number. These are like fractions. the denominator of this fraction is the same as the denominator of this fraction. So because the denominators are the same, you just bring that denominator down as it is, and then you add numerators. So it will be 2 plus 5. 2 plus 5 is 7, and then you write down the denominator as it is, which is 3. So you can't simplify this further. So that is your answer. So take out your exercise book. Take out your exercise books and write today's date. Write the classwork. Let's say I have 2 over 5 plus 8 over plus. Let's not take 8. Let's say I have 3. Let's say I have 4 over 5. Let's say you have such a problem. On the exercise book, try solving this. Solve this. If you had such a problem, how are you going to do this? How are you going to solve this? I'm giving you 4 minutes to solve this. Okay, class, I see some of you did get this answer right. And yeah, that's good, I'm proud of you guys. So, and yeah, time is up. 4 minutes is over now. Let's solve this. If you had such problem, if you had such mathematical problem, if you had such this problem and you're supposed to solve this, tell you guys, it's just quite simple. You just follow these steps that I did. You just do as I did in these other examples. Because they have the same denominator. You bring the denominator down here as it is. The denominator, which is 5. They share 5. They have the same denominator, which is 5. The denominator of here is 5 and the one of here is 5. The same denominator. They are like fractions. So you bring 5 here. And then you add numerators. Numerator, aka numbers below. So it's 2 plus 4. So it will be 2 plus 4. 2 plus 4, which is 6 over 5. And that is your final answer. We leave it like this here because it cannot be simplified further. So, on page, take out your DPE workbooks and open on page 122. Page 122, you will do number 1, number 2, number 4, and number 7. I'm giving you 15 minutes, and then after 15 minutes, we will do the. Okay, because my period is about to end, so we'll do the corrections of the classwork tomorrow during my period. Yeah, we'll do corrections tomorrow. And your homework is on page 153 of Siavula textbook. It's number 1, 5, 6, and 7. To wrap up the whole discussion, to wrap up the whole lesson, if to solve fractions that have the same denominator, fractions that are like to each other, to solve like fractions, what you have to do is just write the numerator as it is and then add the denominators. Then you get the answer. Make sure you leave your answer in its simplest form. Tomorrow we will focus on adding fractions that have different denominators, adding fractions that are unlike each other, adding unlike fractions, and we also focus on subtracting fractions. Thank you so much.